For lesson 7, graphing linear equations in standard form. First, standard form of a linear equation is some number times x plus some number times y equals some number. Now a, b, and c here, they are not the same as the x-intercept and the y-intercept. The important thing here is that a and b are not both 0. Generally speaking, this first term starts with a positive number, and a, b, and c have a greatest common factor of 1, and that puts it in standard form. At this point in 8th grade, we don't have to solve things into standard form. It's just kind of what it looks like. Some of the examples we will do are not actually in standard form, but we can still use these methods. So in the notes, we're going to do I can graph a linear equation in standard form. Now standard form is ax plus by equals c. A is positive, a, b, and c have a GCF of 1. So method 1 is what we've already learned how to do. You're going to solve for y and then graph it in slope-intercept form. So let's go through a couple examples of this. So first, solving for y, we would get rid of the minus 2x by adding 2x to both sides. That gets rid of this. Negative 2x plus 2x is 0, so it's 0. 0 plus 3y is 3y. Negative 6 plus 2x, they are not like terms, so we have to keep both of them. I'll go ahead with 2x minus 6 here. Then, to get the y by itself, we have to divide by 3. Remember, when you divide, you have to divide everything. So everything gets divided by 3. 2 divided by 3 is 2/3. And negative 6 divided by 3 is negative 2. So now it's solved for y. We can identify the slope. The slope is 2/3. It's just the number in front of x. And the y-intercept is negative 2. It's the number that is the constant term. Remember, the slope is the coefficient of the x term, and the intercept is the constant term that has no x on it. After we have identified the slope and intercept, we draw the intercept at negative 2. Then we're going to use the slope to draw additional points. Now the slope is 2/3, so we're going to go up 2 and over 3. And we repeat that as many times as we can on the graph to get a decent line. Sorry about that. Okay. Whoa. That did something really weird. Okay. So we can also go down and back to, or down to back 3. Anyway, we do as many points as we can on the graph using the slope pattern. Oh, I did that one in the wrong spot. Okay, let's get this fixed up. And there, that is done. Okay, let's go through a few more examples. We're going to graph x plus y equals negative 2. We would start by solving for y. We subtract x from both sides, and y equals negative x minus 2. By the way, it could be written as negative 2 minus x. It's going to be the same slope and intercept either way. The intercept is negative 2. The slope is negative 1. Treat that as a fraction so it's easy to graph. Negative 1 over 1. And we start with the intercept at negative 2. Then we do the slope of down 1 over 1. We can also do up 1, back 1, following the pattern up. And we've got our graph. I guess I forgot to throw numbers on the axes. Let me do that real quick. And there, the graph is done. Okay, next example. Negative 1/2 x plus 2y equals 6. We first need to get rid of the negative 1/2 x. We'll plus 1/2 x to both sides. This will give me 2y equals 6 plus 1/2 x. They are not like terms, so we cannot combine them. we'll just do 6 plus a half x. We can divide both sides by 2. Remember, when you divide everywhere. 6 divided by 2 is 3. 1/2 divided by 2. Remember, when you're dealing with fractions and division, you should flip and multiply. It is 1/4. So we get y equals 3 plus 1/4 x. Now the intercept is 3. So I'm going to plot the point at 3. The slope is 1/4. So from that point, I'm going to go up 1/4. And it looks like I can't do it a second time, but I can do it in the reverse direction, go down 1 and back 4. So I get these 3 points, and then I can draw my line. And that is graphed. Okay, negative 2/3 x plus y is 0. Let's go ahead and add 2/3 to both sides, 2/3 x. And that gives y equals 2/3 x. That one's actually done. The y-intercept is not written here because it's 0. Plus 0 you don't tend to write. And the slope will be 2/3. So this goes through the origin. That's the y-intercept. And you go up 2/3. And you can also go down 2 back 3. And you get your line. Let's throw some numbers on here so I know what I counted by. It kind of didn't work out down there. Okay, there we go. All right, next example. 2x plus y is 5. If we subtract the 2x to get the y by itself, we get y is 5 minus 2x. The intercept here will be 5. That's the constant term. The slope is negative 2, so I'll go down 2/1 from that point. And we end up with this nice line. Throw some numbers on here so I know what I counted by. Okay. Whoops. Okay, method 2. The second method for graphing is to graph using intercepts. So step 1 would be to find the x and y intercepts. Note that the x-intercept is when y is 0 and the y-intercept is when x equals 0. So this is, we had this picture in a previous video. Notice that for the y-intercept here, x is 0, and then you get the y-intercept. For the x-intercept, y is 0, and that will give you the y-intercept. Okay, as far as doing maybe a table, if you saw this on a table, you would find the x and y-intercept kind of the same way. The x-intercept happens when y is 0. So there's my x-intercept. Well, let's call it x-intercept is 2. And when x is 0, I get my y-intercept. So here my y-intercept's 1. Okay, that's kind of the idea. On an equation, if we had something like x plus 2y equals 3, the x-intercept you would find by making y equal to 0. So this would just be the x-intercept is 3. And the y-intercept you would find by making x 0. So that would be gone. We can divide by 2 to see what y is. Y is 1.5. So the y-intercept would be 1.5. So yeah, it's not too difficult to find the x and y-intercepts in standard form. Next thing you would do is plot the x-intercept and the y-intercept on the graph. Use any patterns you see to draw more points, and then you can draw your line. Okay, example. Graph x plus 3y equals negative 3. Let's start with the x-intercept. For the x-intercept, y is going to be 0. So this will be x plus 3 times 0 equals negative 3. Well, that completely gets rid of that term, and you just get x equals -3. So the x-intercept is -3. Okay, now for the y-intercept. For the y-intercept, you're going to make x equals 0. So this will be 0 plus 3y equals -3. Well, the 0 is going to be just gone. We can divide both sides by 3, and we get y equals -1. So our y-intercept is going to be -1. All right. So I do see a pattern here of down 1 over 3, which I can repeat a couple more times. I can even go backwards once. And I've got my graph. Okay, let's look at a situation example. You have $6 to spend on apples and bananas. Graph the equation 1.5x plus 0.6y equals 6, where x is the number of pounds of apples and y is the number of pounds of bananas. Interpret the intercepts. Well, first I want to explain why this equation works. 1.5x, well, it's $1.50 per pound, and if we have x pounds, 1.5x is how much we spend on apples. So this is something we spend on apples. Now the 0.6y, if we buy y pounds of bananas at $0.6 per pound, it's going to be 0.6 times y. So this is what we spend on bananas. And then the equals 6, this is the total spent. And this should make sense. What we spend on apple plus what we spend on banana will equal the total spent. So that's why that equation is the way it is. And actually, writing an equation in standard form is sometimes the easiest way to do it. Like here where we're buying multiple things with different prices. Okay, so let's graph using the intercepts. First, if we make x 0, that's gone. And we get 0.6y equals 6. Divide by the 0.6. And we get y equals 10. So I have a y-intercept of 10. Which, by the way, y is pounds of banana. I should make that a capital P. And if it's got to get all the way up to 10, I think I can do that just fine by counting by ones. I'm just labeling every other one. There's 10 pounds of banana. Now let's look at the x-intercept. For the x-intercept, same equation, except this time we're going to make y 0, so that gets rid of all that. So we can divide both sides by 1.5, and this gives us x equals 4. So the x-intercept is 4. Now it'll be pretty easy to fit 4 here. So there's the x-intercept, and I'm going to label it pounds of apples. Now let's make it a capital A. Okay, and then if we connect those together, we get our graph. Now everything on this line represents us spending $6 on apples and bananas. We do need to interpret what these intercepts mean. So first, this y-intercept, it is the 0.010. So we're buying 0 pounds of apples, 10 pounds of bananas. So it means you buy 10 pounds of bananas and no apples. So basically it means you spent all $6 on bananas only. This point here, 0.4, means you spent, it's not 0.4, it's 4.0. It means you spent money on bananas only. No, on apples only. So you buy 4 pounds of apples and no bananas. So you spent all of the money on apples and none of the money on bananas. Now there are some other answers here, like 2.5. You could buy 2 pounds of apples and 5 pounds of bananas. You could actually buy something down in this region, but you would have money left over. To spend the full amount of money, you would be along this line. Now another important thing to point out here, mathematically, this line does continue in both directions. But this stuff doesn't make sense because it would have you buying a negative weight of apples. They don't sell negative weighted apples. All apples have positive weight. So you can't buy a negative weight of apples. Okay, let's do a couple more graphing examples. So 2x minus y equals 8. To find the x-intercept, we get rid of the y. We get 2x equals 8, divided by 2, x is 4. The x-intercept is 4. For the y-intercept, we get rid of the x, we get negative y is 8, and y will be negative 8, therefore. Now for graphing this, since y is a negative 8 and this only goes down to 6, I'm going to count by 2's. That'd be negative 6, negative 8, negative 10. Let's count up by 2's as well. And may as well do my x-axis with 2's. 6, 8, 10. And we've got an x-intercept at 4. Now let's do this in a different color. X-intercept's at 4. Y-intercept is at negative 8. I see a nice pattern here that I can use to draw some more dots and get my line. And that's it. Let's do another example. First, the x-intercept happens when you get rid of the y. We get x equals 6 as our x-intercept. Now the y-intercept is going to happen when we get rid of x. We're going to have to do a little bit of work on it this time. The y-intercept is 2. So my y-intercept is 2. My x-intercept is 6. And it looks like the pattern is kind of a down 1 over 3 pattern. And I've got my line. Okay, in the practice on number 1, you're going to graph by using intercepts. So you need to find the intercepts, then graph them. Don't forget to label your axes, put your numbers on them, whatnot. On number 2, you're going to graph in slope-intercept form. So on this one, you'll have to solve for y first, and then graph. Number 3, find the area of a trapezoid after the transformation xy becomes negative yx. The thing you'll need to remember here is that the area of a trapezoid, these are the parallel sides, you've got a certain height. The area of a trapezoid is 1/2 of the bases added together times the height. Number 4, what's the measure of the interior angle of a regular dodecagon? Dodeca means 12. So that we did this back in Unit 3. Find the interior angle sum of a dodecagon and then divide by 12 so you get the measure of each angle because they'll all share the degrees equally. Number 5, you've got a skydiver parachuting. It gives you this equation. You'll need to graph it. It might be easier for you to graph it using intercepts, even though it is in slope-intercept form, because a slope of negative 10, notice that this is counting by 500, and these are counting by 25. So you would have to maybe go down 500 and over 50, because that is equal to negative 10. And that could be a good way to do the slope, but it's not going to be as straightforward as it might usually be. Number 6, you're going to find the slope from 3 different situations. That's good review. Number 7, you're going to write an equation in standard form. This is a lot like the apple and banana problem, except a boat is $250 a day, gear is $50 a day, and you'll write the equation and graph it over here on the grid. Number 8, consider this equation. 2.5x plus 2y equals 10. You're going to describe a situation that could be modeled by the given equation. This is a lot like the apple-banana problem. In fact, if you want to go for maybe the easiest route, make it 2 different things you're buying. One of them's $2.50 each and the other's $2 each. maybe per pound, per gallon, whatever. And you got $10 to spend. And that could be what this graph represents. You do need to label what the X and the Y axis represent.